Welcome to Episode 33, Azure VPN Gateway and ExpressRoute Connectivity, where we explore how to move application traffic privately between your environments and Azure. Private connectivity requirements usually stem from three drivers: security expectations, predictable performance, and compliance language that discourages open internet paths. In practice, these drivers appear as audit questions about encryption at rest and in transit, contractual uptime targets, and a need to centralize inspection and logging. Private connectivity answers those questions by giving you controlled entry points, verifiable routes, and measurable service levels. The key is to choose the right tool for the job and design with failure paths in mind. Throughout this episode, we will separate site connectivity from user connectivity, compare virtual private network tunnels with dedicated circuits, and show how they can coexist. By the end, you will have a clear mental model of the options, their trade-offs, and how to select intentionally rather than reactively. A virtual private network gateway provides site-to-site encryption between your on-premises network and a virtual network in Azure. The gateway terminates Internet Protocol security tunnels, establishing an encrypted path across the public Internet while keeping private addressing intact on both sides. This matters when you need a fast, standards-based way to extend a branch or data center into the cloud without new circuits. A small scenario helps. A regional office reaches an Azure virtual network over an encrypted tunnel, and applications communicate as if they were on the same private fabric. A common misconception is that a virtual private network hides design flaws in addressing. Overlapping ranges will still cause routing ambiguity. Practically, plan unique address spaces, choose stable pre-shared keys or certificates, document permitted subnets, and monitor tunnel health. With those basics in place, site-to-site tunnels become a dependable bridge rather than a fragile patch. Point-to-site connectivity serves individual users and devices that must reach Azure securely without traversing corporate facilities first. In point-to-site mode, the virtual private network gateway authenticates users and issues them an encrypted session from their laptop or mobile device directly to the virtual network. This model is ideal for administrators, contractors, or small remote teams that need occasional access to private workloads. It shines during staged migrations when a few people must test cloud resources before a broader rollout. A misconception is treating point-to-site as a permanent replacement for enterprise remote access at scale. It is better as a targeted tool than an all-purpose solution. Practical steps include choosing certificate or directory-based authentication, setting split tunneling rules thoughtfully, and enforcing conditional access where possible. With a clear audience and governance, point-to-site provides flexibility without opening a backdoor. Active routing and border gateway protocol bring resilience and dynamic path selection to your tunnels. In an active configuration, you deploy two gateway instances that both pass traffic, which reduces failover time and balances load. Border Gateway Protocol, often called BGP, exchanges routes between your edge and Azure so paths converge automatically when a link fails or a new prefix appears. This matters when you run multiple sites or hybrid topologies and cannot afford manual route edits during an outage. A misconception is thinking static routes are simpler. They are until the first failover, when they become brittle. Practical guidance: keep advertisements concise, prefer shorter summaries, and avoid flapping routes by setting stable timers. Test deterministic path selection so you know which tunnel should carry which traffic under normal and impaired conditions. ExpressRoute provides private connectivity to Microsoft's backbone through a dedicated circuit rather than the public internet. The model involves a physical or virtual handoff at a carrier or colocation facility, a bandwidth commitment, and peering sessions that exchange routes with Azure. The value shows up in predictable latency, higher throughput options, and the comfort some regulators take in non-internet transport. Think of it as extending your network edge into the cloud provider's core with a contracted path and measured availability. A misconception is that ExpressRoute replaces encryption. Many organizations still layer their own controls end-to-end. Practically, expect lead time to provision, coordinate with a provider, and plan dual connectivity for resilience. When set up well, ExpressRoute feels like an internal link even across long distances. ExpressRoute supports different peering flavors, commonly private peering and Microsoft peering, each addressing distinct traffic. Private peering carries traffic to your private address spaces in Azure Virtual Networks, aligning with application workloads. Microsoft peering reaches public services hosted by Microsoft, such as platform application programming interfaces, over the same private circuit rather than the public internet. Choosing the right kind matters because it influences route filtering, security review, and billing. A misconception is enabling everything just in case, which complicates governance and widens the blast radius of mistakes. Practical steps include defining which services must traverse private paths, agreeing on route policies with your provider, and documenting accepted prefixes. With a clear split, your circuit stays organized and auditable. Bandwidth, service-level agreements, and resiliency design become the backbone of a reliable hybrid connection. Bandwidth must match sustained throughput and burst tolerance for your critical workloads, not just average traffic. Service-level agreements describe expected availability, but your architecture determines whether a single fault still causes downtime. Build for dual devices, dual circuits, and, where geography allows, dual peering locations. A misconception is believing a premium circuit alone guarantees continuity. Resilience comes from redundancy and failover choreography. Measure latency and jitter from your actual sites to Azure regions, then size buffers for sensitive applications like voice or transactional systems. Document recovery objectives and test them, so leadership understands what the numbers truly mean. Virtual private networks and ExpressRoute can coexist to blend agility with predictability. Coexistence patterns include keeping tunnels as a failover path for the circuit or dedicating tunnels to specific low-volume flows while ExpressRoute carries bulk traffic. This approach helps during provider maintenance or when circuit lead times do not match project schedules. A misconception is assuming failover happens magically between the two. You must design routing preferences so one path wins during normal operation and the other wins during impairment. Techniques include adjusting border gateway protocol metrics, advertising different route lengths, or toggling next hop preferences. When coexistence is deliberate, you gain options rather than complexity. Route summaries, communities, and filtering shape what networks see and prefer, turning sprawling prefixes into clean, controllable advertisements. Summarization reduces churn and keeps routing tables small, which speeds convergence. Communities tag routes with meaning, such as preferred paths or geographic origin, so policies can act on groups rather than individual prefixes. Filtering enforces what you will and will not accept or announce, protecting your edge from misconfiguration. A misconception is that more routes mean better granularity. More routes often mean more failure modes. Practical guidance. Publish a routing policy, align it with your security stance, and review it with providers. With disciplined summarization and tagging, route behavior becomes predictable and explainable. High availability and failover testing convert paper designs into operational reality. Schedule controlled exercises that disable a tunnel, drop a circuit, or withdraw a route, then watch how traffic shifts and how long it takes. Include application-level checks, not only network probes, because users care about transactions completing, not just packets flowing. Capture logs from gateways, firewalls, and border gateway protocol sessions to build a timeline of events. A misconception is running a single test once. Resilience is a habit, and infrastructure, providers, and teams change over time. Document lessons, tune thresholds, and repeat until behavior is boring. When failover drills feel routine, your risk truly declines. Costs arise from more than monthly circuit fees or tunneling endpoints. They include provider ports, cross-connects and colocation, data processing, and the human time to manage changes. Budgeting requires understanding fixed versus variable components, such as committed bandwidth versus metered egress under certain models. A misconception is choosing the largest circuit for safety without workload evidence. Idle capacity is cost without value. Start with measured baselines, apply reasonable headroom, and revisit after adoption. Consider reservation or term discounts where appropriate, and factor in redundancy as an intentional cost to buy down downtime risk. A clear cost story helps leadership support the architecture you need. Carriers, co-location operators, and internet exchanges play concrete roles in dedicated connectivity. Carriers deliver the last mile and often the managed layer that links your premises to the provider edge. Co-location operators host the physical meet points where cross-connects occur and where you can place equipment close to the cloud edge. Internet exchanges provide shared fabrics that can simplify interconnection under certain models. The ecosystem works when responsibilities are explicit: who owns which device, who monitors which link, and who answers the first call during an outage. A misconception is assuming accountability is automatic. Clarify it in contracts and run joint tests. Strong partner coordination turns a chain of vendors into a coherent service. Choosing connectivity with intent means matching requirements to capabilities and being honest about constraints. Use site-to-site virtual private networks for speed to value, distributed branches, and moderate throughput with encryption across the public internet. Choose ExpressRoute when predictable latency, higher bandwidth, and regulatory posture justify dedicated paths. Combine them when you need quick wins and graceful failover. Throughout, prefer unique addressing, concise routing, measured redundancy, and regular drills. Treat providers as part of your operations playbook, not as distant utilities. With this mindset, connectivity stops being a source of surprises and becomes a steady platform your applications and teams can trust.